Welcome to EPG Pathshala lecture series on data analytics. In this session on data analytics, we will be discussing about what are the various open source tools available for analytics. First, let us know what are the various open source data analytical frameworks, tools and supports that are available, and we will also parallelly learn and understand what are the features which these tools, frameworks or say supports provided in the open source environment. The first and very famous in the recent days is the R tool. We have discussed about plotting graphs and graphical representation of the data using R tool in the previous session. In the recent days, we find R tool has been widely used for statistical analysis as well as visualization, effective visualization of given data. So, what is this R? This R is a programming language and software environment for statistical computing and graphics and available in the website given in this slide. So, you can go to this website, various versions of this R tool are available for download. You will have to identify what type of computing environment you are working with, whether it is a 32-bit or a 64-bit version. Accordingly, download the respective distribution and use it for statistical computing and graphics. This R is a widely used language, statistical language among statisticians and data miners for developing statistical software and data analysis. R is actually an implementation of the S programming language. This slide gives you an idea of the interface in the R environment. So, this R environment contains menus like file, history, resize, windows, packages, etc., etc. If it is, see, this screenshot has been captured during the runtime, therefore, the package menu is not displayed here. Here you have a R console. This is the place where various R commands are executed. This is not the only way in which where you can type the R command and then visualize. You also have an R editor, and in that script editor you can type these commands. Suppose if I want to type a single command, then I can make use of the console itself. Suppose if I want to type 2 or more commands at the same point of time and run them simultaneously, then I can type those command in the text editor and then call that particular file, then automatically all those commands will be executed. Now, here in this screenshot you can find say execution of a plot function which we discussed in the previous session. So, once this command is typed and when you press the enter key, the output of the command will be displayed in the form of a graphic, since this is a plot function, that is a plotting a density function. So, it displays the output, and here this is the place where the R graphics device output is identified. Now, it is this region in which the outputs of various commands are displayed. This region sometimes may be partitioned for displaying multiple outputs at the same point of time. Likewise, there are many features available in R for the purpose of doing various statistical analysis and graphical visual representation of the data. Another important and very commonly used analytical tool is Weka. Weka is a collection of machine learning algorithms for the purpose of data mining task. Weka tool can be downloaded from the website given in this slide. The algorithms actually here are implemented earlier, and it is made available for researchers as well as for decision makers to use it and make decisions. So, the algorithms can either be applied directly on the data set, or you can write your own Java code and then call the respective algorithms. Weka also contains tools or packages for doing data pre-processing, like identifying missing values, eliminating the missing values or the instances containing the missing values using various filter functions. In case if you want to replace the missing values, you can make use of transformation methods for replacing the missing values, and then if you want to select the attributes, selection also can be done using filtering methods. Apart from data pre-processing, it provides support for classification, regression, clustering, association rule mining, and then for visualization also. This particular framework, Weka framework, is well suited for developing new machine learning schemes. They also provide an interface wherein you can find the flow of the process. Here in Weka, we actually have three important supports. One is, as a beginner, you can experiment out with the existing data and the existing algorithms. Secondly, if you are an expert user and if you want to experiment, then you can define your own algorithm and then attach with Weka and then execute your algorithms and evaluate with the existing algorithms. And thirdly, it provides a command line interface wherein instead of the graphical interface, you can type the commands and then invoke the respective algorithms and apply these algorithms on the data set that is available or a data set that is imported and given by you. Here this slide provides you a snapshot of the Weka interface. The Weka interface contains 6 tabs. The pre-process tab is the first tab, because when we do any kind of data analysis, the first step we need to follow is clean the data. So, the entire cleaning process is in general called as pre-processing. So, first pre-process tab is available. Here in the pre-process tab, you have various buttons. Few of the buttons are used for importing data. The data can be available in .arff file format, which is attribute resource file format, or even if you have the file in the form of comma separated files, .csv file, you can import such files. Otherwise, if the data is available in a website or in a web page, you can directly provide the link as an input to this Weka tool, and then you can import the data. Or if you have the data in a database, you can establish a connectivity. Suppose if I have a Java application and connect with help of Weka for calculating or analyzing my data, then I can make use of a Java database connectivity and then establish a connection to database and import it. So, where are these options available in Weka means, say the first command button in the pre-process tab is open file. When you click this open file, it will display a open dialog window, and there you can provide the input file in which you have the data. The second button is open URL. When you click this button, it will display a dialog window wherein you can type the URL where the data is available online. The third command button is, if you have the data in a database, you can make use of this OpenDB command and then connect to a database, establish a connection to database using JDBC connectivity, and then you can import the data. Likewise, you have various options. Once you open a particular data using the Weka tool, the attributes in the data sets are displayed here in this window. So, here you have numbers ranging from 1 to say 12. These are nothing but the various attributes in the given data set. The total number of attributes are 52, that is highlighted here. So, the data which is imported contains 52 attribute. Now, if you want to know how many instances are going to be there, that is how many rows are there in the given data set, that statistics is also displayed here. So, you can find the instances parameter, it is 2000, which indicates there are going to be 2000 records in the given data set. By default, the first attribute will be selected. You can find it is highlighted using this blue shade. Whatever attribute is selected, the statistics related to the attribute will be displayed in this window. So, the attribute that is selected, the name of the attribute, the type of the attribute which is numeric, and what are the possible values like the minimum value associated to this attribute, the maximum value associated to this attribute, the mean, the standard deviation, distribution of the values of this attribute with respect to the given class labels are given here, as a stacked plot, stacked bar plot. Then once you have imported the data, you can make use of various filter functions to do the pre-processing, and then if you want to do classification, you can click the tab classify, select the respective algorithm and use it. Similarly for clustering and association rule analysis also. So this VECA has been very widely and very commonly used among the researchers for doing data analysis. Then the next, and in the recent days you can find another upcoming tool or say frameworks or packages for data analysis is the Pandas. Pandas is Python data analysis library. So Pandas is an open source BSD licensed library providing high performance, easy to use data analytical packages. It provides data structures as well as methods and tools for the purpose of doing analysis, and all these are for Python programming language. So this is a website where you can go and download the respective libraries for doing data analysis in Python. What are the features? The libraries that is provided in Pandas actually provides a data frame object for the purpose of data manipulation with integrated indexing. Alignment of data and integration of data happens very easily, and therefore handling of missing data becomes very easy. Reshaping and pivoting of the data sets is supported. Labeling and various operations like slicing, indexing and subsetting is also supported. You have a group by engine with which you can apply split and then combine or merge operations very easily. Data set merging and joining and library supports for merging and joining is part and part of Pandas. Hierarchical access indexing with respect to high dimensional data, and then mapping this high dimensional data to a lower dimensional data structure is there, and then you can apply time series functionality which works on date range of values, convert that into a frequency conversion, and then you can make use of a sliding window for the purpose of analyzing, apply linear regression, data shifting and lagging, and accordingly you can analyze the time series data. These are the various features that are supported as libraries with respect to Pandas environment. In the recent days you can find Pandas library packages are widely adapted in Python environment for doing data analysis, especially when you have the data in a distributed environment. Python framework are very useful for doing data analysis. Another important tool with which you can do data analysis is Tanagra. So this is a free data mining software for academic and research purpose alone. This Tanagra is available in the given link highlighted in this slide. This particular Tanagra proposes various data mining methods which may be used for exploratory data analysis or doing a statistical learning, machine learning, and then it also provides various algorithms related to databases and accessing data from databases. Tanagra supports several standard data mining tasks like descriptive statistics, feature selection, feature construction. It also provides visualization as well as various factorial analysis on the given data or attribute. It provides support for clustering, classification, association rule mining, and finally it provides a descriptive statistics of the given data, and accordingly beautiful visualization of the statistics can be done. So this slide provides a snapshot of the Tanagra tool. Here you can find say a hierarchical clustering and output related to this hierarchical clustering. So they have imported a data and performed hierarchical clustering using this Tanagra tool. The hierarchical clustering is visualized in the form of a dendrogram. The various data and the corresponding attributes are displayed at the background. Here at the bottom you can find the various types of statistical tests which you can perform, like the Q test, ANOVA test, then you have the gamma test and then the C test, and finally all these tests and the corresponding visualization is also supported by Tanagra tool. The next type of open source visualization tool which is widely used for visualizing graphs and network type of data, and now in the recent days for visualizing social network data, this particular tool is widely used. The tool name is Gephi. Gephi is an open source free visualization and data exploration software applied over graphs and network. It is available in the website highlighted here. Gephi tool is fundamentally used for exploratory data analysis. It provides an intuition oriented analysis by networks and various network parameters. These parameters are manipulated in real time using the Gephi tool. Few examples of such manipulations that which you can do or achieve using Gephi tool, for example link analysis. So, given a network topology, the underlying structure, associations identified in the structure and revealing of the structure and the associations in the structure is greatly done using Gephi tool. Social network analysis is another type of real time analysis which you can do. So, when a social network data is captured, you can create a visualized representation of the social network data in the form of a graph, and then you can extract various subgraphs from the given input graph and perform various social network analysis. A snapshot of the Gephi tool and say running a social network data and visualization of it is highlighted in this snapshot. Here you may find set of data represented in the form of vertices or nodes, and the edges here in the diagram indicates a linkage between these nodes which highlights the relationship between these nodes. Here these nodes can be, the vertices can be say a machine or say a working node, or it can even indicate a social entity like an individual. The colors given to the various nodes indicate some form of similarity highlighted by these entities, social entities or nodes, social nodes, and here you can find say a clustered or grouped visualization of the given data. There are various tabs present both on the right hand side and the left hand side of a given Gephi tool in development environment. You can find various attributes related to the nodes defined here, and also the various data sets and the corresponding files related to visualization of these data sets are present on the right hand side of the integrated development environment. Another important type of open source tool for analysis is MOA, which is short form for massive online analysis. This MOA is a framework for data stream mining. You can download this MOA framework from the link given here in the slide. It includes tools for evaluation and collection, and it also contains a collection of machine learning algorithm. This tool actually provides the following supports. It provides a storable setting for data stream. So, whenever you want to do stream mining, then you can definitely make use of this MOA framework for stream mining. One important feature that is essential for stream mining is storage facility. This MOA provides by default a storage setting for the streams. Why this storage setting is essential is, suppose you want to re-experiment out with the same data means, then you can define your own workspace, have the specific data in that storage space, and then whenever you require you can call the data and then reuse it for various different types of analysis. It has a set of existing algorithms and metrics that are well proven in the history, that is in the research history, and they are adapted for evaluating the stream data. It provides an easily extendable framework for new streams. Algorithms can be newly accommodated, and it also helps you to define your own evaluation metrics and use it for evaluation. These are the major supports from MOA tool. So, a snapshot of the MOA tool is highlighted here. So, here what they are trying to do is they are trying to provide stream data elements as an input and do clustering of this stream data element. Here at the bottom of this framework you can find a window highlighting say the time based representation of the stream data. Now, this is what is very essential when you want to visualize a time based data element, and here in the top two splitted window environment you can find the various clusters that has been created, and finally you can save the clustered output in the file format you require, and then use it for further documentation or analysis. Another important and very famously used data mining or data analytical open source framework or tool is Orange tool. This provides a very beautiful way of representing the flow of analysis. So, this tool supports beautiful data visualization and very effective data analysis both for novice as well as experts. You can download this tool in the URL highlighted here. It provides an interactive workflows with large toolbox. Therefore, these interactive workflows can be created, reused, and then it can also be used for analyzing and visualizing the given data. Orange actually comes up with different types of visualization starting from scatter plot, bar charts, trees, dendrograms, and heat maps kind of visualization are also supported in Orange tool. The snapshot given here is actually indicating the process flow of hierarchical clustering. Here on the left hand side you find various drag and drop kind of tools which provides various functionalities like selection of data, visualization of data, applying say a regression model or any other kind of data analysis that you want to do. All that the user need to do is select, that is click, drag and drop the respective functions. So, suppose if I want to create a file, select the corresponding tool, drag and drop here. Then when you right click on the given icon, it will help you to list down the properties wherein you can find visualizing the data as well as importing data from various sources. Suppose if you want to visualize the file, that is the data available in the file in a table format, then you will have to select this icon, drag and drop here, and then you will have to establish a link between the data that you have selected in this file and then the visualization of the same data in the table format. So, you will have to click and then drag it without releasing the mouse button. It will create an edge connecting this icon and this icon. So, what does it mean? The data from this particular file will be populated into this table, and if you double click on this table you can find the actual data represented in a table format. So, here it tells you the next flow is define the distance metric with which you are going to do the clustering, then you propose a distance map. Here this is the place where you actually call or do the hierarchical clustering algorithm, and the output of the hierarchical clustering algorithm is saved in a data table. So, this indicates the flow by which you perform the hierarchical clustering, or in other words various steps involved towards performing clustering, especially hierarchical clustering on a given data. Another snapshot of the same tool is given here, wherein you can find Venn diagram representation of the data and comparison of the errors with respect to the various outputs given by 3 different algorithms. So, with the help of the Venn diagram you can easily compare what is the error rate between these 3 algorithms. Another type of data mining tool is RapidMiner. RapidMiner is available both as commercial version as well as free versions. Free versions are normally used for academic and research domains. So, it provides an integrated development environment for machine learning, especially deep learning, text mining and also predictive analysis. It provides enormous support for extract, transform and loading processes in a data mining environment. The RapidMiner free basic version actually can be associated to a uniprocessor environment with 10,000 data rows at a particular point of time. The RapidMiner is written in Java programming language and it provides a beautiful graphical user interface for the purpose of working on the given data. So, a snapshot of the RapidMiner is highlighted here. The heat maps of the resulting output is displayed here. Here at the background you can find the box plot representation of the given data or attributes, pie chart representation of the distribution of data, and finally the hierarchical representation of the data is highlighted here. Another snapshot shown in this slide is nothing but a tweet analysis. The tweet analysis has been taken over a period of time. What are the various topics on which various tweets have been generated, it is listed down here, and the circles over here indicates what is the number of such topics on which tweets have been generated. So, the size of the circle indicates the number of times tweets have been generated on a given topic. Root is another important data mining or data analysis framework. So, this is a modular scientific software framework which is used for statistical analysis. This was actually developed at CERN and it is mainly written in C++, but it can be integrated with Python and R. It provides support for statistical analysis, standard mathematical functions, univariate as well as multivariate analysis using neural networks. You can even do image manipulation. If the data is distributed, you can access the distributed data. You can perform distributed computing as well as parallelized way of accessing the data. It provides various databases accesses, 3-dimensional visualization as well as storing the final output in various formats, graphical formats. So, a snapshot of the root object browser is highlighted here. Root also provides various ways, that is GUI tools to build applications. So, here you can find say a simple time series analysis of some data, the various GUI tools that are listed here in the toolbar with which you can do various statistical analysis. NCOG is another advanced data mining learning framework. It actually provides machine learning algorithms like support vector machines, artificial neural networks, Bayesian networks, Markov models, Monte Carlo solutions, genetic programming as well as genetic algorithms. This is actually a multi-threaded and it can scale well for multi-core hardware. It also provides a beautiful GUI, graphical user interface, for the purpose of developing models and train the models using data sets. A snapshot of the ECOG workbench is highlighted here. NodeXL is another beautiful open source template for Microsoft Excel, especially used for visualizing network type of data. It provides say connectivity to online social networks. So, you can directly access social media network data streams and then use advanced network visualization using this NodeXL. So, this is actually a graph representation of a network of 222 tweeters who have tweeted on a specific parameter which contained this hashtag SMT live, or at least they have replied to the tweets that are containing this hashtag. So, maximum of 1800 tweets are there and the network representation of these users is provided by NodeXL framework. NodeXL provides various features like it helps you in computing graph metrics automatically. It is flexible to import and as well as export, that is it can be connected with various other tools like Pajek, UCNet, matrix formats, etc. It has direct connection, it facilitates direct connections to social networks so that you can draw data from various social network applications and directly use it for analysis, and it provides powerful vertex grouping which can be easily done automatically as well as a very effective visualization of the grouping of vertices, that is clusters of vertices can be done. KNIME, that is Constance Information Miner, is another open source data analytic reporting and integration platform. This integrates machine learning as well as data mining algorithms, but in majority this KNIME tool supports extract transform loading. The various features like it supports data types like XML, JSON, images, documents, therefore it can be used for any types of input data. It has various max and statistical functions. It provides a workflow control, thereby you can easily understand what are the various stages involved in your analysis. It can help in integrating with respect to Python, R and SQL and other types of frameworks. It is an interactive in terms of report generation, and it can also be extended for doing time series analysis, image, text and other network type of analysis. Say a data flow of this KNIME tool is displayed here. So, you start with data access, transform the data, do analytics and apply data mining algorithm, visualize the data and finally save the data into formats and use it for decision making. ELKI is environment for developing KDD applications supported by index structures. This ELKI is greatly used for unsupervised method, that is clustering and outlier analysis. The snapshot over here highlights 4 types of column, that is attributes, which are used for performing clustering. WAFL is another machine learning toolkit which provides command line tools for performing various machine learning operations as well as predictive modeling operations. It actually provides various ways by which you can integrate simple scripts with which you can experiment and do the processes. Algorithms that are associated with waveforms actually provide a multi-dimensional analysis of the various data. It does classification, regression, and it also do various pre-processing. Few of the command line applications given in WAFL are WAFL audio for processing audio files, WAFL clusters for clustering, WAFL plot for visualizing, WAFL transform for doing the cleaning processes. In summary, we find there are various contributions from the open source environment for data analysis and visualization. All these open source tools provides some features, also have certain advantages and disadvantages. While choosing a particular tool for doing data analysis, we will have to understand the advantages and disadvantages, accordingly choose the respective tool. If you want to know about more statistical as well as data analytical tools, you can visit to Wikipedia page. The URL of the Wikipedia page where you can find other set of statistical packages are given. Thank you.